This video is part 1 of 2. We're going to be reviewing 10-3 operations with radical expressions. In this first video, we're going to be talking about adding and subtracting with radicals. And then in the second video, part 2, we're going to be talking about multiplying with radicals. So for this lesson, we have the lesson itself and then 6 problems, but they're kind of time consuming. I already filmed this video once and it took 30 minutes. So this is take 2. I'm going to try and condense it. So for adding and subtracting radicals, basically what I want you to think of is whenever you see a radical, number 1, it should be in simplest form. So if you see a radical, like down here, we're going to do examples, they are not in simplest form. First thing we got to do is simplify. Once they are in the most simple form, you can't simplify it more, then you want to think of them as like terms. So look in this problem, we've got a square root of 6 here. And we've got a square root of 6 back here. So these are like terms. Think of it as like 10x and negative 4x, right? If you combine it, 10 minus 4 is 6, so you'd have 6x. Same thing we're going to do here, but instead of an x, you're going to have a square root of 6 behind it. We're not going to touch the square root of 6. We're only going to work with the leading coefficients, okay? Same thing with these middle two, square root of 3 and square root of 3, all right? So again, think of this as like an x, like 10x minus 4x. And then think of these as something different because they're not the same as this. They're different. So we could think of them as like a y, minus 5y plus 6y. So if we were going to simplify this, that's easy, right? We'd have 6x, and then negative 5 plus 6 is positive 1. So we'd have plus y. Done. Same exact thing, but we're going to have these radicals behind us. So we're going to have 6 square root of 6 plus square root of 3, okay? And then they have the math here, right? So all they did was combine the leading coefficients of the matching radicals. Just think of them as like terms. All right, so that's simple enough. We're going to do a few examples with that. What's a little more complex is when the radicals are not simplified. So previously we talked about how to simplify a radical. That's what we're going to do here. So I've got 3 square root of 12. That's where I'm going to start. Just simplify that one term first before I add or subtract anything. 3 square root of 12. I can simplify that, factor that 12 into, let's say, 6 and 2. 2 is a dead end. And I can factor 6 into 3 and 2, right? Real quick, some of you guys are like, yeah, but what if you did 3 and 4? You could have. If we did square root of 12 and we factored it 3 times 4, 3 is a dead end. And then if we factored 4, I get 2 and 2. Look at my numbers, 3, 2, 2. Look at these numbers, 3, 2, 2. It all ends up being the same at the end. It doesn't matter how you start to factor. Okay, so here I am. This is the same thing as 3 square root of 3 times 2 times 2. And remember, I want to pair up numbers under the radical. So I'm going to rewrite this as 2 squared. So 3 square root of 3 times 2 squared. And anything with that little squared symbol, that's its ticket out of the radical. So it hands it over and hops out front. Since we're multiplying everything, when it hops out front, you're going to multiply it by whatever's out here. So I'm going to have 2 times 3. And then under the radical, I still have this 3. It didn't have a ticket out, so he's stuck. Right? So 2 times 3 is 6. So really, 3 times the square root of 12 is the same thing as 6 times the square root of 3. That's in the most simple form, simplest form. Okay, so I'm going to think of that up here as 6 square root of 3. And so then I want to make sure that this is in the most simple form, and it doesn't look like it, right? Usually the number under the radical when it's in simplest form is either a prime number or it's a really small number, right? Because we factored everything else out. So we want to try and factor this 75. So I'm going to use that whole term. Let me scoot this over. 5 square root of 75. And I'm going to factor 75 into, let's do 3 and 25. You could have done something else. 3 is a dead end. 25 would go 5 and 5. Dead end, dead end. Okay, so I'm going to rewrite this as 5 square root of 3 times, and I can pair up these 5s. Oops, sorry. So that's 5 squared. And anything with the squared symbol, that's its ticket out of the radical, so it hops out front. And I multiply it by whatever's already out front. This 3 stays underneath, so this becomes 25 square root of 3. Okay, so now I rewrite this as 25 square root of 3, and what do we notice now? They both have the same radical. They both have square root of 3. So now we're still, it's adding here, so we're still going to add. We're just adding the leading coefficients. 6 plus 25 is 31. So we're going to have 31 and then this square root of 3 behind it. Just like as if it were 6x plus 25x, it would be 31x, right? Same thing. Our radical is just like our like term. It just tells us which terms to pair together. You can check yourself here, 31 square root of 3. Done. Okay, so now we've got these 6 problems. One more thing that I want to go over, it doesn't go over it up here in the lesson, but I did want to review it really quickly, is what to do if you see a radical underneath, a fraction underneath a radical. So for example, let me do it on a separate sheet. If I saw square root of 1/7, is that, what do I do with that, right? Well, it looks nice and neat and clean, right? Okay, square root of 1/7, easy. But you can't leave, it's not in simplest form, just point blank period. Whenever you see a fraction under a radical, it is not simplified. So first thing we want to do, remember, is we can separate the top and the bottom and give them their own radical, their own individual radical. Okay, and now we can take the square root if we have any perfect squares. So 1 is a perfect square. The square root of 1 is 1. 1 times 1 is 1. 7 is not a perfect square, so it's just going to stay. Okay, so is this good? Am I all good? No. Remember, you cannot leave a fraction with a radical on the bottom. That's just the rule. Like it or not, that's the rule. So how do I get rid of this? Well, I don't care about getting rid of the whole thing. I just need to get rid of this square root sign. That's what's not allowed. I can leave a 7 there, it's fine. So to cancel out the square root of something, the only thing that can cancel it out is squaring it, right? Squared and square root are opposites. So how do I square the bottom? I multiply it by itself. Anytime you want to get rid of the radical, just multiply the bottom by itself. And whatever you do to the bottom, you got to do the same thing to the top. Remember, square root of 7 over square root of 7 is really just 1. So I'm just multiplying my fraction times 1. I'm not changing the value. I'm just making it look different. All right, so 1 times square root of 7 is square root of 7. This right here is going to be square root of 7 squared. And like we said, the squared cancels out the radical. It doesn't matter if you have the square root sign under the radical or if it's outside of the radical. Either way, it cancels the radical, right? Either way, the answer here would be 7. So here, I'm going to have a 7 on the bottom. So this becomes square root of 7 over 7. All right, so normally we would be done. Done, that's the rule. You don't have to do anything more. You can leave it. That's 100% correct. Fantastic. In this lesson, since we are adding, and we've already talked about when you have the same radical, that kind of tells us it's like terms. So you add the leading coefficients in front of the radicals. Well, in this case, there's not a leading coefficient. There's not a number in front of the radical. So how could I change this to get a number in front of the radical? Remember, dividing by a number is the same thing as multiplying by 1 over that number. So dividing by 7 or multiplying by 1 over 7, same thing. So I'm going to rewrite this as 1/7 out front and then the radical behind it. So now my coefficient is 1/7 and then I've got my radical behind it, right? This, if I just went ahead and multiplied it back out, I'd end up with this, square root of 7 over 7. I'm just pulling them apart and separating them. So this is my coefficient, and I've got a square root symbol behind it. Okay, so hopefully that's a quick review. Hopefully you remembered that from the last lesson. I think it was 10-2. You can always go back and watch that if not. But we need to know that for simplifying. All right, so moving on. It's already longer than I wanted it to be. Number 1 here. 2 square root of 5 plus 4 square root of 5. They both have the same square root, the same radical. We cannot simplify 5. It's already in simplest form. So we're just going to add the coefficients. 2 plus 4 equals 6. And then we put the square root of 5 behind it. It's just like saying 2x plus 4x equals 6x. Same thing. Okay, next one. Now for this, they do not match. So you would think, okay, well then I can't do it, right? It's done. No, because square root of 8 is not in simplest form. It's not factored all the way out. So if I was going to factor square root of 8, I can factor 8 into, let's say, 2 and 4. 2 is a dead end. And I can factor 4 into 2 and 2. So this is the same thing as saying 2 times 2 times 2. You can pair up any of those 2's. So I get 2 squared times 2. Anything with the squared symbol, hands it over, hops out front. 2 square root of 2. This is the simplified version of this. You can't just look at that and tell, but once you factor it out and pull out all your terms with the little squared symbols, this is what we get, right? 2 square root of 2. So really, I can do this problem once I simplify it. 2 square root of 2, and then the second part is minus square root of 2. So now we're just looking at the leading coefficient since our radicals match. So this is like saying 2 minus 1, which is just 1, right? 1 square root of 2. And when you have a 1, you don't have to write it in front. So our answer is just square root of 2 under the radical. Boom, done. Number 7 and 8 are similar. We have to factor them before we can solve all the way. So let's start with number 7. We have square root of 12 plus 2 square root of 3 minus 5 square root of 3. These are both simplified all the way. It looks like we're probably going to need to simplify this. Sometimes it might be in simplest form already. This doesn't look like it is, so let's just work with it and see if we can factor anything out. Square root of 12, I can separate it into, we already did this up in the example, I thought. Yep, we did. Let's do 3 and 4. That's a dead end. 2 and 2. I can rewrite that as 3 times 2 squared. 2 hands over the squared symbol, hops out front. So I get 2 square root of 3. That's the simplified version of square root of 12. So I can rewrite this as 2 square root of 3, and then add another 2 square root of 3 minus 5 square root of 3. All of my radicals match. So they're just my like terms. I'm not doing anything else with the radical. Now I'm looking at the numbers in front. 2 plus 2 is 4. 4 minus 5 is negative 1. So negative 1, and then my radical behind each one, square root of 3. And then when you have a 1, you don't have to write it. So I can just write negative square root of 3. That's my final answer. And then some of you smarty pants are going, well, wait, I didn't think you could have a negative with a radical. You can't have it under the radical. You can have it out front, that's fine. You can multiply negative anything by a radical, you just can't have the negative sign underneath a radical. Okay, hopefully that made sense. One more like that, number 9. Square root of 8a. Oh, I wanted to keep this problem because it has variables in it. So we're still gonna factor it the exact same way. These two match, they look like they're factored all the way. You can't really divide them out by anything, they're prime. But this guy looks like we can factor it. So square root of 8a, I'm just going to factor it. So what can I divide 8 by? 2 and 4. 4 is 2 and 2. Okay, I don't have to divide the a by anything because I'm just rewriting this. So 8 is the same thing as 2 times 2 times 2. And then I multiply that by a. This is equal to this, right? This is 8a, this is 8a. So now I can just pair up anything. So now I've got square root of 2 squared times 2 times a. This guy can hop out front. 2 square root of, I still have 2 times a underneath, so I can go ahead and multiply them back together and get 2a. So 8a, square root of 8a, is the same thing as 2 times the square root of 2a. And then I still have minus square root of 2a plus 5 square root of 2a. So now they've all got the same thing under the radical, so now I don't care about it anymore. I know they all match, so now I'm just looking at the leading coefficients. 2 minus 1, because when there's not a number, it's a 1, is 1, and 1 plus 5 is 6. So I'm going to have 6, and then I have to put down my square root of 2a. Because remember, if it was 2x minus x plus 5x, it would be 6x. So it's kind of the same thing here. We just use our radical as our, sort of like our variable. It tells us what our like terms are. Okay, so now I've got just two more that we're going to do. This guy right here, we've got, this problem is the only one that I highlighted to do with fractions. There were other problems as well, but I didn't want to spend extra time on them. One example should be sufficient. First thing I want to do here, I notice that I have a fraction under the radical. I know that fractions under radicals are not simplified, so I'm going to have to do something with that. I also have a 54, and I know in my own head that 54 can be divided by a lot of things, right? 6, 9, 3, 2, a lot of numbers. So I'm going to go ahead and try and factor that out because it's not in simplest form either. So I'm going to split that up into 6 and 9. That'll be 2 and 3. Those are both prime. 9 is 3 and 3, both prime. So I can rewrite this as 2 times 3 times, I can pair up these 3's. So I can hand this little guy over and this guy can hop out front. 3 square root of, and then I still have 2 times 3 left underneath here. So I'm just going to go ahead and multiply them back together. And I'm done. So this is the same thing as the square root of 54. One way to check yourself after you factored, whatever number you have out front, just square it and multiply it by the number underneath here. So 3 squared is 9. 9 times 6 is 54. Because all we did was it was underneath here as a 9 and we pulled it out. We factored it out and put it out front. So when we took the square root, it became a 3. But if we put it back under, we got to square it again. 6 times 9 is 54. Okay, easy enough. 3 times square root of 6 minus, now I want to simplify this guy. Okay, so this is just more practice of the same. We've already done one up in the notes like this. So I've got the square root of 1 over 6. And I want to separate my radical signs into the top and the bottom. And then I want to take the square root, right? Square root of 1 is 1. I can't take the square root of 6. It's not a perfect square. It'd be some decimal, and that's not what I want. And then I can't leave a radical on the bottom. So to get rid of a radical, I'm just going to multiply that term by itself. And whatever I do to the bottom, I got to do the same thing to the top. So then I go straight across the top, straight across the bottom. 1 times square root of 6 is square root of 6. This becomes square root of 6 squared, right? So this cancels out with the symbol, and I'm just left with the 6. So normally I would be done. I'm simplified. That's it. In this case, since I'm adding and subtracting, I want to pull a leading coefficient out front. So I'm going to make this 1 over 6 times square root of 6. This and this are the exact same thing. So now I've got my radical and I've got my leading coefficient. 1/6 times the square root of 6. 1/6 times the square root of 6. So now you can see how we've got our two radicals. They both match. So all I'm going to do is combine the leading coefficients. 3 minus 1/6. Okay, now rules of fractions. When I have a whole number and I subtract a fraction, I got to change that whole number into a number with the same denominator, right? When you add or subtract fractions, you got to have the same denominator. So 3 over 1, I got to multiply it by something to make it a number over 6. All right, so 1 times what is 6? 6. And whatever I do to the bottom, I got to do the same thing to the top. 3 times 6 is 18. So 18 over 6 is the same thing as 3. And 18 over 6 minus 1 over 6 is going to be 17 over 6 times square root of 6. That's going to be our answer that we go with. If you then wanted to take it a step further and separate this into a mixed number, it would be 2 and 5/6. You can. That gets confusing to write when it's next to a radical because it looks like 2 times 5 over 6 instead of just 2 and 5/6. So I just leave it as an improper fraction. It's easier to read. But if you were to take it a step further, you would also be correct. All right, last problem we're going to do in these notes is number 15 here. Just a lot of factoring, so that's why I included this example. First one, square root of 50. Let me speed this up a little. Square root of 50, I want to factor that. So I can split 50 up into 2 and 25. 2 is a dead end. And then 5 and 5. So that is 2 times 5 squared. 5 can hop out front. 5 square root of 2. Okay, so square root of 50 is 5 square root of 2. If I squared this and multiplied it by this, 25 times 2 is 50. That works. So I know I'm correct. All right, so this is 5 square root of 2 plus, then I've got square root of 18. So I want to factor that. Make sure it's in simplest form. This here. 18, I can separate into, you could do 6 and 3, you could do 2 and 9. I'm going to do 2 and 9. Okay, so I've got this guy. Now I'm going to do square, that's not an arrow. Square root of 2 times 3 squared. The 3 can hop out front. 3 square root of 2. Okay, so now I've got this guy. 3 square root of 2 is the same thing as the square root of 18, just in simplest form. Now I've got minus the square root of 75 plus the square root of 27. So I want to simplify square root of 75. So I can do, what is that, 5 and 15. I could do 3, let's do 3 and 25. You could do 5 and 15 too. You're going to end up with the same numbers. 5 and 5. So that's square root of 3 times 5 squared. The 5 can hop out front. 5 times the square root of 3. Fantastic. If I square this, 25, multiply it by 3, I get 75. I know I'm right. So 5 square root of 3. Now the one thing I notice is that this does not match this. But it's okay, because once we get everything simplified, we're just going to combine like terms. That's it. No big deal. All right, so now I want to make sure that square root of 27 gets factored, and then I can actually simplify everything. All right, square root of 27, I can split up into 3 and 9. 3 and 3. 3 times 3 squared. That 3 can hop out front. The other one has to stay behind. Oh, sorry. Didn't realize you couldn't see that. So square root of 7 is the same thing as 3 square root of 3. Square this, multiply it by the inside. 9 times 3 is 27. I know I'm right. 3 square root of 3. Okay, so now everything is simplified. All of these have been simplified. So I can combine my like terms. So 5 plus 3 is 8. And they have a square root of 2 behind them. And then negative 5 plus 3 is negative 2. And they've got a square root of 3 behind them. Right? It's like saying these have x's and these have y's. 5x plus 3x minus 5y plus 3y. That'd be 8x minus 2y. 8, our radical, minus 2, our other radical. Hopefully that's making sense to you guys. If you have any questions at all, please let me know.